Okay, today we'll discuss Millman's theorem. What is the statement of Millman's theorem? Millman's theorem. State and prove Millman's theorem, or they can ask problem in the exam. What is the Millman's theorem? Millman's theorem states that in any network, number of voltage sources with internal resistances or series resistances connected in parallel can be replaced by a single voltage source V dash with an resistance in series R dash. So I'll write a diagram like this. This is the resistance connected on a voltage source, positive, negative, that we represented as a V1. Again, another resistance. There will be a one voltage source, positive, negative, and this is where V2. And here one more resistance, and this is positive, negative, and this is voltage is V3. These are connected in parallel. Okay, this we can take the terminal as AB, and this as a node name we can take as a V dash. This resistance we can R1, and this resistance is R2, and this is the resistance is R3. The current it is I1, and this current it is I2, and this current it is I3. This can be replaced by a single voltage source. Can be replaced by a single voltage source that we can represent it as a V dash, and all the resistance can be replaced by a resistance R dash, and load we can connect it again across the load terminal. So where V dash is given by sigma V into G divided by sigma G. So Millman's theorem states that in any network, number of voltage sources. Here, number of voltage sources in this example we are considered V1, V2, V3 with internal resistances. What is the internal resistances here? R1 and R2 and R3 are series resistances connected in parallel can be replaced by a single voltage source V dash in series with the resistance R dash. Suppose if it is an impedance, then we can call it as a impedance. So suppose if here the circuit contains impedance, that is AC circuit, then we can define like this. In any network, number of voltage sources with internal impedances or series impedances connected in parallel can be replaced by a single voltage source V dash with an impedance in series, that is Z dash. So where V dash is given by sigma Vg divided by sigma G, and R dash is given by 1 over sigma G. So proof. What is the proof for this circuit? Proof. You consider node. Apply the KCL at node V dash. So okay. Apply the KCL, Kirchhoff current law, at node V dash. At node V dash. So what we know? Current, no, Kirchhoff current law is based on the current, that is algebraic sum of the current meeting at a point is equal to 0. So therefore I1 plus I2 plus I3 is equal to 0. Here we are taken as a V1 as a higher potential because moving that the current is moving now this side. Therefore we are taken here V1 as a higher potential, V dash is a less potential. So therefore what is the current flowing I1 means, that is V by R, V1 minus V dash divided by R1 plus I2 V2 minus V dash divided by R2 plus V3 minus V dash divided by R3, that is equal to 0. So this You can write like this: V1 by R1 plus V2 by R2 plus V3 by R3. Okay, minus V dash, we can take the common factor. Then we can write it as 1 by R1 plus 1 by R2 plus 1 by R3, that is equal to 0. We can write like this. Again, this you take a right hand side. So I'll take this as a right hand side. So V1 by R1 plus V2 by R2 plus V3 by R3 is equal to V dash into 1 by R1 plus 1 by R2 plus 1 by R3. V1 by R1, 1 by R1 is nothing but a G1, because we know that G is equal to 1 by R and Y is equal to 1 by Z. Okay, resistance and conductance. Resistance is in ohm, conductance in is mho. What is the relation between resistance and conductance is G is equal to 1 by R. Therefore, 1 by R1 we can write it as a Z1. And similarly, this is V2 into Z2 plus V3 into G3 is equal to V dash into, this is G1 plus Z2 plus, we can write it as a G3, because 1 by R is equal to conductance G. So therefore, V dash we can write it as, V dash is nothing but V1 G1 plus V2 Z2 plus V3 G3 divided by, this is Z1 plus Z2 plus G3. Okay. So this is similar to earlier what you have defined. Now this is nothing but sigma Vg in general, that is sigma G. That is defined in the law, the statement now. Same. Again, what is the R dash? And R dash is given by 1 by sigma G. 1 by sigma G. That is equal to 1 by G1 plus Z2 plus G3. Similarly, for N series. Similarly, for the N series. Similarly, for N sources. N sources. We can write it as V dash is equal to sigma Vn into Gn divided by sigma Gn, and R dash is given by 1 over sigma Gn. This is the statement and proof of Millman's theorem. Understood this?
Yes, sir.
Yes,
Okay.
sir.
Yes.
Based on this, we'll solve the problem. Okay, note on the question now. Question: calculate the current. Calculate the current through 3 ohm resistor. Through 3 ohm resistor using Millman's theorem. Using Millman's theorem. Calculate the current through 3 ohm resistor using Millman's theorem. So this is the circuit. This is the resistance, and here it is a voltage source, and here there will be a resistance here, and here a resistance, and this is your voltage source, and here it is 10 volt, and this is your 20 volt, and this is 2 ohm, and this is your 5 ohm, and it is 3 ohm. So in this problem, what is the load resistance here? What is the load resistance?
3 ohm.
3 ohm. This you write it according to circuit. That is our statement circuit. We can write like this, no, resistance and then voltage source. Again another resistance, then on this voltage source. And here it is a load, it is connected here. So this we can take it as a 2 ohm and this is 10 volt. And this is 5 ohm and this is 20 volt. And this is 3 ohm. We are connected the same circuit in this way as well because too easy to solve. That is all connected to one node only. Node, see there are 2 ohm, 3 ohm, 5 ohm connected to this node only, same node. Here also we connected the same node. Negative is connected and another 3 ohm resistance is connected to ground only. We connected same one. It would interchange according to our convenient. That's all. So what is the V dash? No, what is the formula? V dash is nothing but because
G1.
two resistance is there, no, they can take V1 G1 and V2 Z2 divided by G1 plus G2. G1 plus Z2. That is equal to. So V1 is 10. G1 is 1 by 2 plus 20 into V2 into this is our Z2. Z2 is 1 over 5 plus G1 is 1 by 2 plus 1 by 5. This is nothing but 5 plus 4 divided by 0.5 plus 0.2, that is equal to 9 by 0.7. This is how much it is a V dash. V dash is equal to 12.857 volt. Then calculate R dash. What is R dash formula? R dash is equal to 1 by Z1 plus Z2. That is equal to 1 by 2 plus 1 by 5. That is equal to 1.4285 ohm. Then you have to find out what is the current flowing this load resistance I. Current flowing the load resistance. That is I is equal to what is the current flowing through the load resistance? You write a circuit. Original after simplification according to Millman's theorem, you write a circuit. So this is your V dash now here. This is the V dash, that is positive, negative, and V dash is how much is 12.857. Okay, and here resistance. This is your resistance. This is R dash, that is 1.4285, and then here another resistance. It is this resistance. This is the load resistance, that is 3 ohm. In that calculate what is the current. It is I. What is the current? It is I in this problem. I is equal to V by R. Apply KVL. That is 12.857 divided by sum of the resistance 3 plus 1.4285. So how much it is? I value 2.9 amps. 2.9 amps. This is the answer. Understood this?
Yes, sir.
Okay.
Yes, sir.
We'll go to the next problem. Shall I go to the next problem?
Yes, sir.
Okay. Next problem, no doubt. Using Millman's theorem, find IL, find IL, find IL through RL, for the network shown in figure. For the network shown in figure. So this is the diagram we can take. Resistor, and then this is here, and here also there will be one resistor, and here 1 voltage, and again this is a resistor, and this is your voltage source, and this is your RL. So this is V1 is equal to 20 volt, and V2 is equal to 40 volt, 40 volt, and this is V3 is equal to 50 volt, 50 volt, and this is your RL, that is 9.4 ohm. The current it is IL, and this is your 2 ohm, and this is a 4 ohm, and this is the 5 ohm. This was asked in one exam, 10 marks. Solve this problem.
Sir, V dash is 31.5789 volts
Ah,
and R dash is 1.052 ohms.
yes, correct. So solve this. V dash is equal to V1 Z1 plus V2 Z2 plus V3 G3. This is the formula, divided by Z1 plus Z2 plus G3. That is equal to V1 is 20 by 2 plus 40 divided by 4 plus 50 divided by 5 divided by 1 by 2 plus 1 by 4 plus 1 by 5. So this is equal to, after simplification, we'll get this is 30 divided by, this is zero point 0.5
Sir,
plus,
IL is 3.021.
correct. IL is 3.02.
1 amps.
Is zero point 0.2. So this is nothing but 30 divided by 0.95, that is equal to 31.5789 volt. R dash is given by 1 over sigma G, that is equal to 1 over Z1 plus Z2 plus G3, that is equal to 1 by 2 plus 1 by 4 plus 1 by 5, that is equal to 1.0526 ohm. So write a circuit, Millman circuit. This is the Millman circuit. This is a V dash, and this is your R dash, and this is your RL. This is your RL, and current it is IL. So therefore IL is given by V dash, that is 31.5789 divided by R dash plus RL. R dash plus RL, no? RL. R dash plus RL. What is R dash plus RL? R dash plus RL. That is equal to 31.5789 divided by R dash is 1.0526 plus RL. What is RL value is given? It is 9.4. After simplification, we'll get 3.0211 amps. This is the answer. Next, note down. Next problem. State Millman's theorem. State Millman's theorem. Using Millman's theorem. Using Millman's theorem. Find current through the load resistor. Find current through the load resistor RL for the circuit shown in figure. For the circuit shown in figure. So this is the diagram. This is negative, positive, and here resistor negative, positive, and here resistor. This is negative, positive, and here there will be a resistance here. Resistance. So this is where 4 volt, and this is 2 volt, and this is for 10 volt. Class ಇದೆ 10 volt. This is where 4 ohm, and this is 4 ohm, and this is 4 ohm, and this is RL is equal to 10 ohm. This was asked in one exam for 10 marks.
All voltages are leaving, so we should take negative.
Yes. In the original circuit negative. Now this you take positive negative. The last one you take positive negative. Here, this you take positive negative. This is your positive and negative. Positive and negative. So V dash is equal to earlierly positive negative positive negative. Negative is grounded. Here negative positive negative. Positive is grounded at ground point. So therefore you have to take V dash is equal to first one is minus V1 G1 minus V2 Z2. Other one is positive only. Negative is connected to ground. Therefore you take positive only plus V3 into G3. So divided by Z1 plus Z2 plus G3. That is equal to minus 4 by 4. Again it is minus 4 by 4. 4 by 4, and here this is 2 by 4 no here.
1 by 3 volts.
Second case 2 by 4. Voltage is 2 no here. 2 by 4 plus 10 by 4. 10 by 4 divided by G1. G1 is again it is a 1 by 4 plus again it is 1 by 4 plus 1 by 4 only. This is nothing but 4 by 3 volt. R dash is given by 1 over G1 plus 1 over G2 plus 1 over G3. That is equal to 1 by 4 plus 1 by 4 plus 1 by 4. This is nothing but again 4 by 3 ohm.
Both voltage and resistance are same, 1.33 volts and ohms.
Okay. Write a circuit. So here it is we got a positive only, no? Therefore you can write it as positive negative. Negative is grounded, and another resistance is there, load resistance. You write This is your 4 by 3 and this is voltage also 4 by 3 and this resistance is I 10 ohm. Find out what is the current IL. Then current IL is equal to 4 by 3 divided by 4 by 3 plus 10. This is 0.12 amps. This is the current. Next problem, no doubt. Next problem. Find the load current I. Find the load current I in the circuit shown in figure. In the circuit shown in figure by using Millman's theorem. By using Millman's theorem. So this is the resistor, and here it is a 1 voltage source. And again there will be a resistor, and this is 1 voltage source. And here a resistor, 1 voltage source. And it is here 10 ohm. So this is where 1 volt, and this is a 2 volt, and this is 3 volt, and it is here I, and this is for 1 ohm, and this is a 2 ohm, and this is 3 ohm, and this is your 10 ohm. Solve this problem. All of you solve this problem and tell me the answer. V dash is equal to, use the same formula, V1 G1 plus V2 Z2 plus V3 into G3 divided by Z1 plus Z2 plus G3. Okay. So V1 is 1 by, resistance is 1 plus 2 by 2 plus 3 by
V dash is
3.
1.636.
Huh?
V dash is 1.636 volts.
Okay. Note down how much you're getting. 1, 2. So divided by
R dash is 0.545 ohms.
plus G1 plus G2 plus G3. This is 1 by 1 plus 1 by 2 plus 1 by 3. How much it is?
1.833.
1.833, na?
Not the answer, sir. Answer is 1.636.
Not answer,
I
V
told
dash.
only the denominator.
V dash, V dash.
V dash is 1.636.
1.636. 1.636 volt. All of you got the same answer now?
Yes, sir.
Okay, R dash.
Yes, sir.
R dash is nothing but 1 over sigma G. That is 1 over 1 by R1 plus 1 by R2 plus 1 over R3. That is 1 by 1 plus 1 by 2 plus 1 by 3.
545.
How much?
0.545.
0.545 ohm. Then write a circuit. This is positive, negative, and then a resistance, and here also resistance. So this is your 10 ohm, and this is your IL, and this resistance is 0.545 ohm, and the voltage will be 1.636 volt. So therefore IL is given by 1.636 divided by 5.455 plus 10. How much it is?
0.155 amps.
0.155 amps. This is the answer. All of you got the same answer, no?
Yes, sir.
Okay, let's go to the next problem again. Next question, note down. Use Millman's theorem. Use Millman's theorem to find current. Use Millman's theorem to find current. To find current flowing through. See the board. 2 plus J3 ohm impedance. 2 plus J3 ohm impedance for the circuit shown in figure. This also asked in one exam. For 12 marks he asked in that exam. And this is the circuit, a resistor, and this is the voltage source, positive, negative. And here a resistor, and this is positive, negative. And here there will be a one resistor. And again it is connected one current source here. Again here this is resistance and then inductance. This is where 2 ohm and this is the 2 volt, and this is 3 ohm and this is the 4 volt, and this is your 4 ohm. Current it is 10 amps, and here it is a 2 ohm and this is a J3 ohm. This circuit is not under standard circuit like to convert directly to the Millman's theorem. Here what you can do now, here they're given one current source, no, and the resistor is connected in parallel. This you converted into again voltage source. First you convert this into voltage source and redraw the circuit. After converting to current source into voltage source, we can write like this: positive, negative, and here also there will be a positive, negative, and you convert this is again it is positive, negative, and the remaining it is a load that you have tried load. This is the load. So here it is a 2 volt and this is a 2 ohm, and this is 3 ohm, and this is 4 volt, and this is 4 ohm. V is equal to I into R. I is 10, 40 volt. I into R. I is 10, R is 40 volt. Remaining resistance and inductance you write as it is. Now we can convert easily. Now here now we can convert V dash. V dash is nothing but according to theorem V1 G1 plus V2 Z2 plus V3 G3, V3 and G3. So divided by here again G1 plus Z2 plus Z3. So V1 is 2, is 1 by 2 plus 4 into 1 by 3 plus 40 into 1 by 4 divided by 1 by 2 plus 1 by 3 plus 1 by 4. After simplification, how much you get? 11.385 volt. If you simplify, then you will get answer is 11.385 volt. Now, same circuit, you find out what is R dash now here. Then it is R dash is nothing but 1 over Z1 plus 1 over Z2 plus 1 over G3. That is equal to 1 by 2 plus 1 by 3 plus 1 by 4. So is equal to 0.92308 ohm ಬರುತ್ತೆ. Simplify ಮಾಡಿರಿ. Now write a
Yes, sir.
circuit. Write a circuit. This is the V dash. This is the where V dash and R dash. And the load as given. What is the load given that you write? So V dash is given as 11.385 and R dash is given as a 0.92308. Load is how much is given? This is 2 ohm and inductance is a J3 ohm. Then find out what is the IL here. What is the IL? Current flowing to the load to find out. So IL is given by, okay, apply the KVL 11.385 into divided by sum of the resistance 0.92308 plus 2, 0.92308 plus 2 plus J3. So after simplification, simplify and tell me the answer, how much you are getting.
Sir, 2.717 at an angle of minus 45 point,
After
45.73.
yes, after
Two,
simplification
two,
we'll
po-
get a
2.7,
2.718 at an angle of minus 45.744
45.745.
degree amps ಬರುತ್ತೆ. ಇದು ಬರುತ್ತೆ. We'll get this. This is the answer. All of you got answer. You have to practice. I told you from the beginning only. Practice is a must for this subject. You don't read this subject. You have to take a problem. You have to work out. Then only you can score good
Sir,
marks.
44.25 enough, sir. Answer.
Huh?
Minus 44.25.
Okay, okay. 45 ಬಂದಿದೆಯಲ್ಲ?
44.25, sir.
Okay. Okay. Any doubts to the class?
No, sir.
Okay. 1 second.